Okay, we're going to take a look at 2009 question number 4 through 6 on the free response here. So question 4, this is your question dealing with inference. You had a 95% confidence interval for the difference in mean response times. So it's pretty nice. You're talking about confidence interval, it's saying difference in mean response time. So it's either a two-sample t-test or a paired t-test, or confidence interval, I mean. So I have calls from a north fire station and a south fire station, so these are going to be independent groups, so it's going to end up being a two-sample t-interval. Okay, so for part A, the way this question was graded has some different sections to it. There's 4 sections, and section 1 is checking your condition and naming conditions and naming the test or the interval. Section 2 is the mechanics. Section 3 is going to be your interpretation or your conclusion, and then section 4 is going to be part B. Okay, so for section 1, for your conditions and naming the procedure, you have to do both of the following. Indicate the appropriate procedure as a t-confidence interval for the difference in means by name or formula, so two-sample t-interval is what we're looking for. And then you need the large enough, which we're calling the nearly normal condition, stating that these sample sizes are large enough so that the central limit theorem is going to apply. But you have to reference a number, in this case 25 or 30, and we used 30. Okay, so random, that stated that there are random samples. It's very important that you're saying samples, or both samples were randomly stated. Independence, I can assume one response time, that the response times are independent. 10%, 50 and 50 are less than 10% of all responses respectively from each station. Independent groups, very important. I have to assume these two groups are independent, the north and the south fire stations. Nearly normal, this is what they were talking about specifically for conditions. Both sample sizes are large, and I have to put this reference in here, greater than 30, therefore the central limit theorem is going to apply. Here's the name, conditions met, use the t-model for a with degrees of freedom 96. I got that from the calculator for a two-sample t-test. So I have the name of the test, I've checked the nearly normal condition with reference, that's going to earn me essentially correct. For the mechanics of this question, they show a correct confidence interval either by displaying numbers in the formula or by writing the numerical interval. Okay? So I have mechanics, I have the sample mean from the north station minus the south, plus or minus this critical value. There was 96 degrees of freedom, and we want 95% confidence. So you can use inverse T on your calculator, or I have 95% confidence, 96 degrees of freedom, so it's going to be a little bit above 1.984. You'll see I used 1.985. I have a two-sample t-interval, so I have my formula for the standard error right here. I have the difference in sample means, two-sample. We're never, ever, ever using this formula. I can cross that right off. I'm looking at this formula here, except I have the sample standard deviations that I'm going to be substituting in. That's where I got that. In my calculator, I just did two-sample t-interval, plugged in the data, and ended up with this. So on my rubric, I have a correct confidence interval, and I displayed the numbers, 96 degrees of freedom, critical t-value, confidence interval. Okay, so this is going to earn me essentially correct. For section number 3, the conclusion. If you correctly interpret the confidence interval, not the confidence level, so we're not saying in many random samples, 95% of them, we're not saying that. The interpretation must indicate that the difference in mean response times. Difference in mean response times. All right, we're 95% confident that the true difference, there you go, difference in mean response times between the two fire stations, and I'm very explicit how I did it, north minus south, is between that and that. Okay, where did I get that from? Right here. Difference in mean response times between the two fire stations, okay, using the context that I was given. Okay, so I have that in context, and I talked about the difference in mean response times. That's going to earn me an E. Section 4, this is part B, looking to see if our confidence interval supports this claim. It's essentially correct if you make a correct conclusion in context, supported by the fact that 0 is contained within the 95% confidence interval. If you don't talk about context, it's a P. If you make an incorrect explanation, saying his belief is wrong, or accepting the null, it's incorrect immediately if you don't make a reference to a confidence interval or you have the wrong conclusion. So here, I wrote out the null and alternative. That's not required. You don't need to do that. It just helped me think about the question. Since 0 is included in the 95% confidence interval, make sure you're being explicit. Tell what confidence it is. I would fail to reject the null. There's weak evidence to support the member's belief that the two stations have different mean response times. Again, taking context here. Weak evidence to support his belief that the two fire stations had different mean response times. Okay, that's going to earn me essentially correct for part B, or section 4. I have 4 E's. That's going to earn me a 4. 4 parts. Each E is worth a point. P is worth a half a point. I 0. Okay, take a look at question number 5 next. And let's find that. Okay, in question number 5A, I want to interpret a p-value in context. So this is just one of those abstract skills that you want to make sure you understand. It's if the null is true, then there's a blank % chance of seeing a difference this or more extreme by natural sampling variation. Well, I'm just going to put this in the context using the null that they gave me. So taking a look at the scoring guidelines here. Okay, there's 3 parts, A, B, and C, and they're scored as E, P, or I. So 3 components: correct probability phrase. The p-value of measures the chance of, includes the word as large as or something similar. This or more extreme is what I taught to you guys. Correct conditional phrase. If the survival rates are the same. That's talking about the null being true and in context. If you got all 3, it's an E. 2 out of 3 is a P. And last is obviously an I. So, question 5. Here we go. If the survival rates for the 2 treatments are equal. Right there. If the survival rates for the 2 treatments are equal. So that's if the null is true, then there is a 7.61% chance, I just took my p-value and multiplied it by 100, of observing a difference this or more extreme by natural sampling variation. So I have the as large as by this or more extreme. I have the conditional part if this is true, and I have context. I have all 3 components. That's going to earn me an E. Part B, based on this p-value, what conclusion can be drawn? And we're using a significance level of alpha equals 0.05. All right, scoring guidelines. Essentially correct if a correct conclusion, failure to reject the null, is provided with context and linkage to the p-value. If you have a correct conclusion, but one of those 2 things is missing, it's a partially correct. If you're saying, you should never be saying accept the null, that in my mind should be an I. If you make the wrong decision, you're right away going to an I. Okay, so since the p-value is high at the alpha equals 0.05 level, there's my linkage to the p-value. We fail to reject the null. There's my decision. There's weak evidence, and I'm just going to take the alternative here and put it into my sentence. There's weak evidence that the treatment that uses CC alone produces a higher survival rate. There's weak evidence that the treatment that uses CC alone produces a higher survival rate. There's my context. I have those 3 components. That's going to earn me essentially correct. Well, there's not 3 components, but those parts. Part C, I want to know which error, type 1 or type 2, could have been made and what a consequence is. So there's a couple things we're looking for here. The type of error named is consistent with the conclusion in Part B. So I failed to reject the null in Part B, so the only type of error I can talk about is type 2 error. And then the second thing is a consequences provided in context that's consistent with your conclusion and is specific with regards to the treatment. The consequence must address how heart attack patients will be treated as a result of the error. Okay. So remember, type 1 error is the null is true and you reject it. I did not reject the null, so it cannot be a type 1 error. So type 2 error, because if the null is false and we fail to reject it, that's a type 2 error. So that's me answering the first part of the question. A consequence is that more lives could have been saved using CC alone. Okay, so let's take a look at this here. Because the null was not rejected, a type 2 error could have occurred. That's the first part. A possible consequence is that this other procedure would continue to be accepted when in fact CC alone would result in a higher survival rate. Okay, so I've addressed both of those things. What error was made and what a consequence was. That's going to earn me an E. Okay, I have 3 E's. That's going to earn me a 4. Your goal is to get a 2 or higher, and you can see on the scoring guideline how to do that. All right, let's move on to question number 6. Remember, your goal for question 6 is to get a 1 or more. 1 or more. So in part A, this is a great opportunity to get that 1 point. Define the parameter of interest and state the null and alternative hypotheses. Well, I see units, I'm dealing with quantitative data, and I have 1 sample, all right? So what am I interested in? I'm interested in this. I want to know if the automobile manufacturer was misleading customers by overstating the average fuel efficiency of a particular car model. So I need to know of all car models, this specific one, not just the 10 cars in this sample. So grading part A looks like this. It's essentially correct if you state the hypothesis with a lower tailed alternative and correctly identifies the parameter of interest by referring to the mean of the population in context. So you could use the words population mean, true mean fuel efficiency, mean miles per gallon of all cars of this model, mean miles per gallon of this car model. Okay, so you'll notice here the true population mean average fuel efficiency of this car model. I've talked about that, so I've met that component. The other thing is that mu is less than 27. You'll notice I do not have that correct. I have mu is greater than 27. So that would be partially correct. And the reason is it's that the consumer organization is interested in testing. Okay? So they think they misled them. Well, by misleading them, if it's more than 27 miles per gallon, then the customer is going to be happy. So that's why it should have been less than. So you'll see why I made a mistake there. Okay, part B. All right, let's take a look at the grade rubric here. Okay, it's essentially correct if the student states that the large values, or values greater than 1, indicate a right skewness, and you have to justify the answer on how it affects the relationship between the mean and the median. Okay, so basically talk about the mean being greater than the median. Okay, so there's a couple different scenarios for partially correct here, but you have to state the 2 things, that it's going to be a large value of this statistic and that the mean is going to be greater than the median. So for this question, I said a distribution skewed to the right has a mean greater than the median. Therefore, if the skewness ratio was large, it may indicate the population distribution is skewed to the right because the numerator is greater than the denominator. So I've talked about it being large. I've answered that part. And I talked about the mean being greater than the median when it's skewed to the right. I've talked about that part. That's going to earn me essentially correct. Keep in mind, your goal is 1. Even getting a P on A and a P on B, that gets you to 1 point here. Okay? Anything you earn past 1 is just extra. But 1 is definitely within reach. Okay, part C, my favorite question on the entire test, and something that they've been asking more and more that we've talked about. So they run a simulation of 100 samples, each of size 10. And they said in the original sample, this statistic, this is kind of like our test statistic almost, is 1.03. I'm sorry, our sample statistic, 1.03. And based on this value in the dot plot, how likely is this? Well, really, I'm trying to get a p-value here. What's the chance that if this was true, I got something of 1.03 or more extreme? Well, there's 1.03 or more extreme. If I count up these dots, I get 14 out of my sample size of 100. It happened 14% of the time. So as far as grading part C goes, it's essentially correct if you state it's plausible that it came from a normal model and you justify the choice with numerical evidence from the dot plot describing the relative location of this value of 1.03. 14% of the values are above 1.03. Again, guys, they've been asking these questions more and more and more lately. Okay, so as you take a look here in my answer, I got that simulated p-value 14 over 100 is 0.14, which I got and I showed on the dot plot. Since the p-value is high at the alpha equals 0.05 level, we fail to reject the null. There's weak evidence that the original population is skewed to the right because a difference of 1.03 or more extreme was 14% likely. So I think I've discussed both things needed to earn credit here. Going back to the rubric, I state that it was plausible that it came from a normal distribution. I don't know. I say there's weak evidence that the original population is skewed to the right. So maybe that first one I didn't do. The second one I definitely did. So I might give myself a P. Let me see if it says anything in the notes about that. No. Okay. States that the sample came from a population that is skewed to the right and justifies. Okay. So, yep. Oh no, but I didn't state it came from a population skewed to the right. Let's see if it says anything down here. Not really. I think I really didn't come right out and said it's reasonable that it was normally distributed, so I think I did a poor job of communicating that. That's going to be a P. Okay, part D. This is where they want you to come up with your own statistic to measure skewness. There's multiple answers here. You just have to justify it. So here's how you're going to get credit or not get credit. It's essentially correct if you define a reasonable statistic and identify the values that indicate a right skewness with an explanation of how that right skewness is going to affect the components of the statistic. Okay? So let's just take a look at what they did here. They said max minus median divided by median minus min. If the distribution is skewed to the right, the distance from the median to the max would be larger, so the ratio should be greater than 1. So let's take a look at what I have. I did quartile 1 plus quartile 3 divided by 2. And I said if the formula is greater than the median, so I'm going to compare this to the median, then I would expect, or then I would conclude the distribution is skewed to the right, because that would represent more variation between quartile 3 and the median than quartile 1 and the median. So let's go back to the guidelines here. You'll notice a couple different possibilities here, but they're not comparing them to 1, or these are compared to 1 greater than 1. It's going to be skewed to the right. Let's see. The test statistic must be a formula that produces a single numerical value. Mine did. This greater than less than is not a statistic, and any statistic that uses summary values not in the table is incorrect. So I don't know. I'm trying to think. I think I did a good job of explaining why it would be skewed to the right. I don't think I do have a statistic because it's just one value. I guess I don't like the idea that I have to compare it to the mean. I don't have something specific here. I have something like this, but I'm not dividing it by the mean to see how it's, but I am comparing it, and I think I explained that. This one's kind of tough. It's kind of between an E and a P. I just don't think I did a great job communicating. I'm not sure. I talk about if the formula is greater than the median, so I have that. Then I concluded skewed to the right because that would represent more variation between Q3 and the median. I really don't like what I have. It's not very clear. I should just be getting a numeric value and then comparing it and going from there. So I'm going to give myself a P there. So this ends up being a P is worth a half a point because there's 4 parts. E's are worth 1 point. So I have 3 P's and an E. So that's going to end up being 2.5 points. I'm supposed to use a holistic approach. Most times this is going to end up rounding down. I'm just going to assume that it's going to round down here. It's very rare that it rounds up. So I'm going to earn a 2 for that question. Again, my goal is at least a 1. Every point you earn on question 6 is worth 3.125 points. So hopefully you guys found this helpful, and we'll see you in class.